Okay, let's go. So first things first, my apologies for the long gap between the last episode and this one. I fell ill for a couple of days, so it was a bit difficult to find time to make this recording. Anyway, I'm feeling well again and I'm back. So let's get started. So where we left off last time is we implemented panning and zooming. So look, you can zoom in and you can also pan around. So that's nice. Was short and sweet. Let's get back to what we want to do today, and that's create objects. And objects in this sense will be things that workers can install. For instance, it could be a kitchen or a workplace or anything basically. The key requirements will be that objects need to be installed using an install object job, and this will have some requirements. So you will need to have an item in your inventory that represents the object to install. So if you want to install, for instance, a kitchen stove, you will need to have a kitchen stove in your inventory. You need to install on the correct tile types. So for instance, perhaps you need flooring to install on, or you can only install outside on grassland. It's up to you, but basically we want to be able to set a requirement for the type of tile you install on. You need to be at the correct location, so we don't do any sort of remote installation. And there needs to be enough space. So it needs to be unobstructed. There can't be any other objects or blocking tile types in the way. And objects can be of arbitrary size. So they don't have to be a one by one size. They can also be larger than that. So we need to take account of that in looking into a required space. And later on, we will make it that objects can create jobs for workers to perform, for instance, to craft something. And this is how we can implement actual behavior for the objects. But today we will focus on the install object job, setting the requirements. And we will do it in a slightly different way than the earlier tutorials. And we will set up the most basic of the data structures for the object and the role to keep track of objects. Then we will immediately start writing tests and add more code as we go along to get those tests working correctly. So those tests will probably have a lot of compile errors at first because we're still missing properties, we're still missing functions. We will add those on a case-by-case basis right until the test succeeds and gives us a green back. So that's what we're going to do today. Let's start up Xcode and let's get started. So let's close a couple of things. So first, what we need is a new data type. In our model, we'll create a new file called object.swift, and this will represent an object. So this will be a structure, and it will have at least a name, and it will have size. It will have an install time. So how long does it take to install this particular object? Some might take longer than others. And let's add a sprite property right now as well. And to keep it sort of consistent with the other ones, like items and entities and tiles. And let's say which tiles are allowed to install it on. So we call these allowed tiles. Then we'll create an initializer. Let's see, so I want to have some default values. That's the main reason why I'm creating this one. So I want floor as the default allowed tile if you don't pass in anyone. A sprite can be an optional that defaults to nil, and then the sprite can be either the sprite passed in or the name if nothing was entered. The install time by default will be 1, and the size by default will be a 1x1 vector. And that's it for the initializer. I want to add one more thing right now, and that is what I would call an object item. And this is an item that represents the object to install if it's in your inventory or if it's lying around somewhere in the world. And I simply want to be able to take an object and create the required item from it. And we do that using a name. It will have the same name. The sprite will be this one, sprite, plus we'll add an underscore item, so we can use a different sprite to represent the installed object in the world, which might be quite large, as well as the item as it's in your inventory, which might be a bit smaller, or it might look like something placed in a box or something like that. And we'll give it a preferred pickup stack size of 1. We don't want to carry around dozens of kitchen stoves to install, for instance. So normally we assume that if you want to install one, you only pick up 1. So that's it for now for the object. We will very quickly go into the world, and where we have our entities variable here, we'll create an objects variable, and that will be a dictionary that maps from a vector, like where it's installed, to an object. And for now, that's it. So we're not done, but let's get to creating tests. So we have a job tests here, and let's create a new test. So let's see. So the first test I want to do is a func and test install object job. So let's see. So let's create a world. Let's create an object. And let's give it a name. It'll be some object. It'll be have a size of 1. And we can install it on void tiles because we have an empty world to start with. Let's see if this compiles, because autocorrect isn't working, and that sometimes means there's a syntax error somewhere. Okay, but no problem yet. So let's see. So we have our world, our object. Let's create an entity that can do the installation. So we have our entity, and this one will have a name, example entity. This one will have a position of 0, and we'll have a job. And this will be a job. And what we want is something like a create install object job, but we don't have that one yet. So let's create this one. Let's go into job, and where we have a convenience builder functions, let's add a static func create install object job. This takes an object install, add a position, that's a vector, and this will return a job. And we'll return a job with a new job call, which we don't have yet, so we need to do a bit more. Let's create a job call called install object. This will take an object as an associated value. This now means that we also need to give it a description. Let's return install object.name. Okay, now we can go to the job call and say we want to install an object. And the object we want to install was passed in at the position. we want to have a build time, and this will be the object.install time, and we need some requirements. And these requirements we don't all have yet, but for now let's assume we simply don't have any so far. Let's first see how far we get with this, because now we can continue writing our test. So we have an install object job now defined, and we need to pass in an object to install it. Now, for instance, position 0, and we put this job on the stack of the entity, and we make sure that the entity has one of the objects to install in the inventory. This way we can later check if this one was actually installed. And for now, let's assert that the world has no object at position 0. And then we say entity update in the world. After updating the world object at position 0 should have object.name as the at this position. So we should find, if we're looking at the world at this location where we try and install the object, that we now have an object there. And also, let's see, we have an entity, and this has an inventory, and it has an object item that we want to look at, and we expect no item there anymore. So let's see if this test at least compiles, and then let's see if it runs. So our switch should be exhaustive. Okay, now we can use autocomplete somewhat to manage this. So we have a complete job function that now also takes into account the install object function, or the install object goal, and we need to implement it. So let's say we have an install object. Well, then our world.objects current job.target position should be the object, and we should pop the job from the stack. So let's see if this now works. Let's go back. So let's try and run this test again. So at least we can run the test, but we get an error message, because we still have the object in the inventory instead of being 0 as expected. Notice that we already have the object installed, otherwise this one wouldn't have passed. This basically means that we need to add a requirement, and the first requirement will be the item requirement. So let's see, so we have items, we need an item stack, and the item we want is the object.object item, and the amount we need is 1. So let's go back to our test. And we now see that it has passed because the item gets consumed during the installation. So that one was nice and easy. Let's write some more tests, because we have a couple of more requirements. So one requirement we have is that if we install our object in a non-empty tile, that should fail, because we only can install if there's room enough. So we again need a couple of things. So we need a world, an entity, and an install object job. Then we need to make sure that the world object at location 0 is some object. We give it, pass it a name, we call it a pre-existing object. Then we push the create install object job. We push the install object job to the entity, and we make sure that the entity has the object item in the inventory. Then we can call entity update in the world, and we can start asserting that now the world dot objects 0 dot name should still be the pre. Let's copy paste this one, it's a bit less risky. So the installation should have failed, meaning that the existing object is still found at this location. Also, the entity's inventory should still be 1. Let's see if this compiles. Alright, so we need to unwrap this optional. We already gave the default value. Okay, so let's run it. Well, it compiles, but the test fails because it was over, and we now find the sum object here instead of the pre-existing object. So what is happening is that we don't have a requirement yet that the location to install should be empty. So what we should do is we should go into our job and add a requirement that we should add a requirement of something like a noObject. So let's create one. It's a new requirement called noObject. And let's go into our job and add this noObject requirement. Let's try and build. This will cancel because when we're checking the requirements, we haven't implemented the check for the noObject requirement yet. So let's go into our entity and let's look into the case that we have a noObject. What we should do is we should see if in the world objects the job target position, if this one is not nil, so there is something there, then we should return false. Let's see if this builds. Right, let's see if this helps the test. Let's run the test again. And the test now passes. Very nice. So let's see, what else? What kind of other requirements do we need to test? So we're testing on the non-empty tile. Let's see, let's test our install object on the wrong tile fails. So basically we're testing the situations where installation fails. So let's take our world. Let's take all this stuff again. And let's see that we require this to be installed on the floor. We have our job. We'll make sure that we have in our world, we'll set the tile at position 0 to a wall. So we make sure that it's not a floor. And then we push the job to the entity's job queue. And we make sure that the inventory has the object that needs to be installed. Then we update the entity in the world, and then we can make some assertions again. So the first assertion will be that the world, the object to position 0 is still nil. So let's assert nil. That might be a bit easier. So this should be nil. Oh, we don't need that there because I was asserting nil. So nothing should have been installed. And also we will assert that our inventory is still 1. So it wasn't destroyed. So let's see if this test runs. So we have a compiler error first. There's our error. Let's run it again. Oh, right. So missing an argument title there. So this compiles correctly, but the test fails because we're not taking this tile type requirement into account. So quite similar to what we did before, we first create a new requirement. And we call this one tile allowed tiles. And we call this one tile. Then we go into a job and add a new requirement for the allowed tiles. The allowed tiles will be our object.allowed tiles. So if we and this will again fail to build because we need to take this one also into account in where we're checking the requirements. So after our noObject, we can add the new requirement for the allowed tiles. So we take our allowed tiles. If our allowed tiles contains world tiles position, and we can avoid it if default. If this one is false, so if where we try and install the tile is of the incorrect type, we return false. So let's see if this fixes or makes a test pass. Another test passed. Very cool. So we installed this case. So another thing we can test is what if we don't have the correct item in our inventory. So let's see. So we create a test, install object missing object item spawns a fetch job. Again, we need to have our world. We also make sure that our world has the correct item somewhere in it. So we create a new item stack. An item object item amount 1. And we push this job on the entity's job stack. So the entity does not have the object to install in the inventory, but it is available in the world. So we want to see if this spawns a fetch job. So let's see. So we have a top job, and this should be the install object job. Because that's the one we push, so it should be there. So let's switch on the job call, and if it's an install object job, no problem. If it's anything else, then we fail the test. Top job should be an install object job. Now we update the entity in the world. And after this, let's see what the top job now is. It should now be a fetch item job because it's trying to find the object to install. So let's see our entity jobs. We take the top one, we peek. Then we again switch on the top job call. And in case it's a fetch items job, then that's okay. But if it's anything else, we fail the test. It should now be a fetch items job. Let's see, this should run. Let's see, we have typo, so this should be a switch statement. Let's see if this compiles. So let's run it. Right, this test passes, meaning that if you don't have the item in your inventory, the worker will try and find it somewhere else. So the stack system of our jobs is still working. So let's write the last test. So create the test install object at the wrong location wants a move job. So we want to move towards where we need to install if we want to install something and we're not at the same position already. So let's create again all this stuff, but this time we want to install the job somewhere else. We take our entities inventory for our object item and make sure it has it in the inventory. We also make sure that we put it on the stack. And again, we first check if the top job is an install object job. So we can copy paste this code here. Then we run the update. And now the top job should be a move location job because we are not at the correct location to install. So this should now be a move to location job. And let's run this test. And this fails because we haven't yet added the requirement to always be in the correct position. So let's go back to our job and let's add a position requirement. That's one that we created earlier, so we can reuse it. And now if we run again, this should work. Let's see. So let's see what kind of job we have then at the top job. If it's not what we expect. So it's still an install some object job. So what am I missing? We have the object to install. Oh, we should make sure that we allow it to be installed anywhere. So let's run this again. Okay, so cool. It succeeds now. Now I want to do a little bit of refactoring because we are checking literally everywhere if an object exists in the world by checking for nil values and so what I want to do is I want to create just a couple of helpers, just like we have our items management, we have our objects management, and this one we will create a function called object exists at position, and this will just return a Boolean value. And we will use another helper function to get the object at a position. This will return an optional object, and then we will look into our object position and object and object. If the object position dot x and the object position dot x plus the object the size dot x contains a position dot y. So basically we're going, this adds the ability to look for the size of the object. And we do something similar as for the y coordinates. So we take our object position dot y to the object position dot y plus the object size dot y. This should contain a position dot y, and if it does, we return this object. If we can't find anything, we return nil. Then we can, if the object exists at position, we can do object at position is unequal to nil. So let's go back to our test. And there was this test where we were looking if an object exists at a position in the non-empty tiles. So let's see, where did we do this check? On the wrong tile. So we, instead of asserting nil here, what we'll do is we'll take our assert false object exists at position 0, and this should be false. So let's see, this should still run the same. Also, our other tests would also still all run correctly. Okay, so they all pass. Well, I think that's it for today. Next time we will look at visualizing these objects. Thanks for watching and have a good day. Just one more thing. So in our where we're checking the noObject requirement in entity, we are checking directly for the nil value of a specific location. What we should do is use an object exist at position function here. This way we look at the total location or all the locations for which the object would need to be installed based on its size instead of just the target position. So yeah, so this should now be working correctly. Again, our test should run. Cool. Okay. So, I'm sorry about that. And see you next time.